Hello everybody and welcome back. We are starting a new unit now on something called rational expressions and rational functions. So a rational function is really any function that can be written as a ratio. And we say that it's an expression that can be written as a ratio of polynomials. So you might remember that polynomials are these terms we looked at. We looked at quadratic polynomials and linear polynomials. So just for example, if I had something like x squared plus 5 over 2x minus 1, the numerator, x squared plus 5, is a polynomial, and the denominator is a polynomial. And when I combine them as a ratio, that's a rational expression. Now, when we talk about rational expressions, we're going to run into this idea of non-permissible values, which is basically we cannot have a situation where we have a denominator that equals 0. So with any of these rational functions, we always have to look at the denominator and say, is there a situation there? Is there some value of x that I could put in that would give me a denominator that's 0? Essentially, I cannot divide by 0 because that is undefined. So if we take a look at a bunch of examples here, and some of these are really simple and some of them are more complex, all of these are ratios, and in each case, I can find the non-permissible value by looking at my denominator. Now remember that we only have to look at the denominator. That it doesn't matter what the numerator is. You can have anything on top. You can have 0 on top of your expression. You just can't have it on the bottom. So for this example here, I can see that I cannot have x equal to 0, and I also cannot have y equal to 0. If x is 0, then it doesn't matter what y is. The whole denominator is going to become 0, and same thing for y. Whereas here, I've got 3x squared plus 2 over 5. 5 can't be 0. I don't know what that would mean. So in this case, there are none. There are no non-permissible values. When we get a slightly more complicated expression here, like 4x squared over 3 times 2x plus 1, remember that this 3 doesn't really matter. That's fine as it is. But inside here, inside the brackets, this 2x plus 1, that expression could be 0. So basically, I get a situation where I have 2x plus 1 cannot equal 0. And that might be something you haven't seen before, but this is it like not an inequality, but it cannot equal, and so this is the same as an equation. We can still do our same algebra rules. Like I could subtract 1 from each side and get 2x cannot equal -1, and then divide by 2, and I get x cannot equal -1/2. And so in that case, you could see that if I substitute -1/2 back in there, I would get 2 times -1/2 is -1. Plus 1 is 0, and the whole thing just falls apart all over again. If I have another expression here, like a minus 2 over a squared minus 7a plus 10, it might not be obvious that there are any non-permissible values, but what I'm going to have to do is I'm going to have to factor that denominator just to see. So my numerator remains a minus 2, but I need to factor out the denominator and see if there are possible non-permissible values. So I'm looking for two numbers that are going to multiply to positive 10, but they're going to add up to -7, and that would be -2 and -5. So this is going to factor to a minus 2 and a minus 5. Now, because these two expressions, a minus 2 and a minus 5, are being multiplied by each other, then I have a situation where if either one of them becomes 0, then the whole denominator becomes 0. So basically, I have a minus 2 cannot equal 0, and I have a minus 5 cannot equal 0. And I can solve both of those to find my non-permissible values. So essentially, a cannot equal 2, and it also cannot equal positive 5. So to find the non-permissible values, you're going to figure out if there's anything in the denominator that could equal 0, and then that tells you the value that's not allowed to happen. So when we have these rational expressions, we always have to find the non-permissible values, but then we can still sometimes simplify by factoring out the top and factoring the bottom and seeing if there are any common terms that we can get rid of. The key here to remember is that we always have to state the non-permissible values, and we always have to do that before we simplify. If we eliminate something, that doesn't eliminate the non-permissible value, which is something maybe we'll talk about more in class. So I can see here that right away I've got a situation where 5x cannot equal 0, which is really just another way of saying that x cannot equal 0. Okay, I'm not so much worried about the 5. But once I do that, now I can factor out anything from the top. For example, 5 becomes 5x plus 2. And I'm going to divide that by 5x. And I can see I have a common factor of 5 in the numerator and the denominator. And so if I cancel out that 5, I'm left with x plus 2 all divided by x. It would be really tempting. It really looks like maybe, hey, can we divide that x by that x? But remember, this is x plus 2. So there would have to be a factor of x on the entire numerator in order to be able to factor that on the bottom. So even though it doesn't look like it, that's as simple as that's going to get. When we look over this next one here, so we've got similar situation. For my non-permissible values, remember I only care about the denominator. So I've got 3x cannot equal 0, which is just basically x cannot equal 0 again. And then I can see here that I've got an x already factored out. So I can actually cancel that x with that x, because that x is a factor of the entire top, which is going to leave me with a value here. Let's see what's left behind. I've got 2x minus 3 all divided by 3. And that, again, is as simple as that's going to get. Okay, so we've got a slightly more complicated rational expression here, and that's because both the numerator and the denominator are more complicated polynomials. They're quadratics. So in order to see if I can simplify them, I'm going to have to factor them both. Now, I also have to factor them in order to see if there's any non-permissible values. When we get this, I find it simpler to just treat them as separate polynomials and then bring them back together at the end. It's going to be a little bit less complex. So let's first see if I can factor 2y squared plus y minus 10. Now, this is a situation where my a value is not equal to 1, so I'm going to have to use decomposition to factor this out, which means I need to find two numbers that are going to add to my b value, which is 1, but that are going to multiply to my a value times my c value, which is minus 20. So those two numbers are positive 5 and negative 4. Positive 5 and negative 4. And I'm going to decompose this original expression into 2y squared. And it doesn't matter which way I decompose it, but maybe I'll do minus 4y plus 5y minus 10, pardon me, minus 10. And then I can see that I can group these, group these two and group these two here and factor. So I've got 2y bracket y minus 2 plus 5 y minus 2. And remember, when I'm doing decomposition, I know I've got it right when I've got the same term inside the brackets after I've factored. So I can now factor that out, and I get y minus 2 times 2y plus 5. And so that is just factoring my numerator. Factoring my denominator, luckily, is going to be a little bit simpler because I've got y squared plus 3y minus 10. And so I just need to find two numbers that are going to add up to 3 that are going to multiply to minus 10. So that's going to be positive 5 and minus 2, positive 5 and minus 2. So this will factor into y plus 5 and y minus 2. Okay, let's put this all back together. We've done a lot of work already, and we've only just started the problem. So I'm now going to rewrite this as my numerator is y minus 2 times 2y plus 5 all over y plus 5 and then y minus 2. Now, it's really important. We've done all this work, and it's easy to just kind of charge ahead and want to solve and start simplifying things. But remember, I still haven't stated my non-permissible values. So when I look at this here, before I simplify, I have to find the non-permissible values. I'm just going to take a look at my denominator and say, okay, I know that y plus 5 cannot equal 0, which means y cannot equal negative 5. And I also know that y minus 2 cannot equal 0, which means y also cannot equal positive 2. So my two non-permissible values are right there. Now that I've stated those, I can go back to my original expression and see if there are any terms that are in common. And in fact, I've got y minus 2 on top and y minus 2 on bottom, so those two cancel out. What I'm left with here, this whole thing simplifies then to 2y plus 5 divided by y plus 5. Now that is the final answer. And that sure looks like it should simplify more, but remember, I can't take out a common factor across the whole top and bottom. So that in fact is as simple as it's going to get. All right, we're going to try one more example here. And again, I'm going to run to this situation where I have to do decomposition because my numerator has a quadratic with an a value that's not equal to 1. So I need to find two values that are going to add to 11 that are going to multiply to 24, so that's 2 times 12. Well, that would be 8 and 3. 8 and 3. And so my numerator becomes 2n squared, let's say plus 8n plus 3n plus 12. And I'm going to kind of separate these out and factor them. So I have 2n, n plus 4 plus 3 times n plus 4, which is going to factor out to n plus 4 times 2n plus 3. Whew, it's a good reminder that this stuff still exists. In terms of the denominator here, my 2 times n squared minus 16, that doesn't look like it's going to factor until I remember that this is a difference of squares. So something squared minus something else squared factors into n minus the square root of c times n plus the square root of c. And so those come together like this. So this whole expression could be rewritten as n plus 4 times 2n plus 3, all divided by 2n minus 4 n plus 4. Now a reminder that before I simplify, it's before I simplify that I have to do my non-permissible values. So I'm just going to look at this right down there and say, okay, n minus 4 cannot equal 0, and n plus 4 cannot equal 0, which means n cannot equal plus or minus 4. So there's my non-permissibles. Now I can go back to my expression and I can look for common factors, which in this case is n plus 4, and I can cancel both of those out, and then I'm left with 2n plus 3 over and then I'm left with 2n plus 3 all divided by 2 times n minus 4. And that is my final simplified rational. Okay, that is it for rational expressions.